Welcome to Glencoe Algebra 2. This is our second lesson. We're going to be in section 1-3 called Solving Equations, and today we're going to focus only on examples 1 and 2. So let's start with a few definitions. Okay, a few important definitions. First one is open sentence. The book defines open sentence as any math sentence containing one or more variables. One or more variables. Okay, so a math sentence would be something like 5x plus 2. That would be a math sentence. It has a variable in it, and it would be considered an open sentence. The second definition that we want to take a look at here is equation. An equation is defined as a math sentence. That equates or states that two math expressions are equal. So pretty much an equation is anything that states equality between two math expressions. So something like that 5x plus 2 equals 7. Both sides of that are math expressions, and they're separated by an equal sign, so it's stating that they are equal. We're going to see some examples of both of these things in the examples that we're talking about. So let's move forward and let's get to a little bit of more vocabulary that's going to be even more important in these first two examples. So math vocabulary. What we're going to be doing in example 1 and example 2 is we're going to be taking verbal expressions for math and writing the mathematical open sentence or equation that goes with it, and vice versa. So we're going to see sentences of actual words and vocabulary that we're going to have to make into math sentences, and then we're going to see math sentences and we're going to need to write the actual words that you would use to describe those. So I think it's important to start with some vocabulary so that we know what we're looking for when we hear, or see add, subtract, multiply, divide, etc. So addition. How do you know when you are supposed to add, or when the vocabulary, the words, what words should tell you that you need to add? So some of the ones that I kind of jotted down that I think we should pay attention to are more than. Okay, so the expression more than should lead you to think, oh, okay, I need to add some things here. Another way to say that is increased by. Sorry for the sloppiness there. Increased by would also be addition. And the other one that I think is important is that anytime you're talking about some things that are added, you may need to talk about their sum. Okay, so we might say the sum of something, the sum of 2 and a number. And then what we're doing is we're actually talking about the answer to that addition problem. And that's where the sum part comes in. Similarly, for subtraction, addition is more than, subtraction therefore is going to be less than. Increased by for addition, decreased by for subtraction. And then instead of the sum, if you're talking about the answer to a subtraction problem, you're going to be talking about the difference of two difference. Okay. How about multiplication? Multiplication, we're going to be looking for times or multiplied by. Times or multiplied by. And the answer to a multiplication problem is called the product. Division, we're going to be talked about more divided by, and then the answer to a division problem is called the quotient. And then the other thing that shows up in here are variables. So where do you put the variable? How do you know when we're talking about a variable? Sometimes the variable is given a specific letter to use to represent that variable, but sometimes it's just referred to as a number. If it's a number, I mean, they might, like I said, just say a number. So you may have a number plus 7, or a number increased by 7, and you would know that you would write a number, you would represent it as a variable, and you would increase by, so you would add 7. And that's what these examples are going to sound like. So let's take a look at the first example. The first examples are, given the words, write the numbers and symbols. So let's move over here. Example 1, the instructions say write an algebraic expression to represent each verbal expression. So the verbal expression here, ignore the hand, sorry about the hand there, is 2 more than 4 times the cube of a number. So we need to write some math that shows 2 more than 4 times the cube of a number. So I think sometimes it's helpful to locate the variable and see and kind of work from the variable. So the variable in here is right over here. It says a number. So we're going to use the number, the x as a variable. Our number is going to be x, so I'm just going to put an x down here, x. What are we doing to x? Well, this says the cube of a number. Okay, so the cube of a number means take x and it should be raised to the 3rd power. What are we doing to that x cubed? Well, this part right here says we are doing 4 times the cube of the number. So 4 times means multiply, so we're going to do 4x cubed. And then it says 2 more than, and we talked about more than as being addition. So to our 4x cubed, we're going to add 2. And it doesn't matter what side we put that on, we could do it as 2 more, just to stay with the order of kind of the way the verbal expression goes. So here we have an open sentence. There's no equal sign. And so this says 2 more than 4 times the cube of a number. We would write 2 plus 4x cubed. Let's look at B. It says the quotient of 5 less than a number and 12. So for this one, since it starts with the quotient, I think if you think about it, let's go back to these vocabulary words for one. What I'd like to point out is that anytime you have the sum, the difference, the product, or the quotient, you're kind of going to want to start there. They're going to give you important information because you're going to have the word and. The sum of this and that, the difference of this and that, the product of this and that, and the quotient of this and that. And that's going to give you a way to kind of separate the problem, like you're going to see with this example 1b. So 1b, again, it says the quotient of 5 less than a number and 12. And since it starts with the quotient, I know that there's going to be division. So I'm actually going to write it more like a fraction. I'm going to put this line here, and I know that I need the quotient of something on top and something on the bottom. And so this and right over here is going to be an important separator because it's going to separate the top, which is going to be everything here inside my parentheses, and the bottom, which is going to be what comes after the and. The and gives you a before and after, which is kind of like your top and your bottom. So I feel like it's kind of easy here to say, all right, there's only one thing after the and so that's going to be our 12, that's going to be our bottom. I'm going to go ahead and put 12 on the bottom. So 12 on the bottom is because, again, it's after the and. So that means the top is everything before the and. And here we have 5 less than a number. Okay, so 5 less than a number says, well, I have a number, and I need 5 less than that number. So my number, x, I'm going to subtract 5 from it. And here I have x minus 5 divided by 12. The 5 less than a number part is before my and. That tells me that it's on the top of my quotient, on the top of my division problem. I could also have written it as x minus 5 divided by 12. And again, the and being, or the 5 less than a number being before the and tells me that that's first in the equation, and that I'm dividing then by what's after the and, which is 12. Let's move over to the next screen where you can try the guided practice. On this screen there's 2 guided practice problems. Now you should pause this video and go ahead and try the guided practice. Again, you want to read each of these verbal sentences and try to write the mathematical sentence with numbers variables and symbols only, and the answer to these guided practice questions will be given to you at the end of this video. Go ahead and pause now. Okay, let's move on to example 2. Before we do example 2, now's a good time to point out that questions like example 1, where they give you the verbal expression and ask you to write the algebraic expression, will only have one possible correct answer. The way the verbal expressions are constructed, they should only get you one specific algebraic equation or expression. Example 2, where you're given the algebraic expression and asked to give the verbal sentence, there could be multiple possible correct answers to these. And that comes back to the use of different vocabulary, saying something times something as opposed to the product of this and that. So we could have multiple answers for these. So just know that, so that when you check your answers to these extra practice questions, the guided practice questions, in case they're a little bit different, it doesn't necessarily mean that they're wrong. It could just be that you used a different vocabulary word to handle that one. So let's look at example 2. This says, write a verbal sentence to represent each equation. So you see the equation here in A is 6x equals 72. Now I'm going to say that most of us can say that this is 6 times x. But what is x? Remember that when we talk about the variable, we generally don't state it as the variable that's actually there. We can, and in this case I will do that, but this one is kind of straightforward. I do want to look at it two ways. So let's start with this. 6 times, well, 6 times what? It's a number. And we can state the variable that we want to use specifically by just stating a number x. So 6 times a number x. Now how do we say equals? We could say, you specifically use the word equals, but what happens oftentimes is you see the word is. So 6 times a number x is 72. Okay, pretty straightforward there. 6 times a number x, the x being the name of the number that we're talking about, is 72. And that one is kind of straightforward. I would imagine that most of us right away can look at 6x and state it as 6 times a number x without any difficulty. I do want to write it another way using one of those other vocabulary words. So I'm going to use product. So this time I want to call it the product of what and what? Well, 6 and a number x is 72. So here you can see that I use the word product, and just as we stated with the quotient example from example 1, we have the product of something and something else. Okay, so the 6 and the number x are the things that we are multiplying together there. So we want to be conscious of what vocabulary words we're using. I also think it's helpful to start at the left and move to the right whenever possible. So let's move down and look at B. And again, using that start to the left, move to the right sort of algorithm, we're going to start with the very first thing, and that's n. That's the variable. So we can just start with a number n. I want to caution you, though, here that using plus, a number n plus, we don't really like that. So we're going to go with a number n. And how are we going to say that that number needs to have 15 added to it? Let's use that increased by. A number n increased by 15 is, because we're talking about the equal sign is 91. And again, that's not the only way to do that. We could talk about this as the sum of two numbers. Instead of stating that the number n is increased by 15, we could say the sum of a number n and 15, right? And that's just another way to say the same thing. The sum of a number, namely n, and 15 is 91. Okay, so the is 91 part and the is 72 part didn't really change, but we can state the other side of this expression on the left of the equal sign in different ways. So again, writing the verbal sentence when you're given the algebraic expression, they could sound a little bit different, and there are multiple ways to write those. But when you're given the verbal sentence and asked to write the algebraic expression, there's only one right answer. Now I guess you could say that there's a different form you could write it in, namely the way that we did the quotient problem, where we wrote it one way as a fraction and the other way with the sort of division symbol in between the two numbers. But there's only one right answer for those. So let's move over and try some guided practice here. Here's guided practice for example 2, 2a and 2b. Pause the video now and give these a try. Okay, now that you've given those a try, we're going to keep moving here. We finished example 1 and example 2. The next thing we're going to do is take a look at the answers to the guided practice. Guided practice answers, 1b should have been p cubed plus 4p. 1b is 3 times the quantity of x minus 8. Those parentheses are important there. And then 2a and 2b, here is one way to write each of these algebraic expressions as a verbal sentence. So the difference of a number and 5 is -2, and 2 times a number is equal to, so there they used equal to, the difference of that number squared and 4. So you will notice in a couple of these examples, namely 1a and 2b, that they did reference the same number twice. Okay, so that's p cubed plus 4p, probably said something like a number p raised to the third power or cubed plus 4 times the same number p. So we do want to be specific and make sure that we're stating that we're talking about the same number so that we use the same variable. They're both p's. In 2b, they were both c's, right? 2 times a number is equal to the difference of that number, the same number squared, and 4. So just some little things to look at and try to pick up in the vocabulary. So good job today with examples 1 and 2 in section 1-3. Remember, you can access the book at connected.mcgraw-hill.com. Accessing the book 24/7 book access there. Today we focused on section 1-3, examples 1 and 2, and that's located on page 18 and 19. Remember, we only did examples 1 and 2, and your homework is located on the next screen. Please complete the check your understanding for examples 1 and 2. It's only 6 questions. Come prepared for class to start by reviewing these answers. Thanks a lot, and we'll see you tomorrow.